I think this is so amazing that we talk about this application with 25 microsecond cycle time based on EtherCAT. And I'm really proud about this because EtherCAT is basically a backoff invention. So we invented EtherCAT in the year 2003 already. But when we talk about EtherCAT, we need to talk with Oliver because he is one of our really deep experts about EtherCAT. So good morning, Oliver.
Good morning, Roland.
Good to have you. Now, what is the secret behind this performance from EtherCAT?
This is simple. It's because of the unique functional principle of EtherCAT. So unlike with traditional field bus systems, with EtherCAT we are processing the data on the fly. So that means while the frame is passing the devices, the data is written into the device or read out of the device. You can put that into a picture like with a high-speed train that is not stopping at a train station, and the train stations are the equivalent of each EtherCAT device, and people can still hop on or hop off the train while the train is passing by. And this is the same what is happening in every EtherCAT device, and therefore we are avoiding a lot of delays which you typically have in traditional field bus systems. And with the EtherCAT chip, which is a standard chip within each EtherCAT device, we cannot only achieve that great performance in processing the data, we can also synchronize the devices in a very precise way.
Yeah, but I mean, there's still, the frame still needs to go through the entire network, so there must be a time delay. So how can you make it happen to synchronize then each individual part of this?
Thanks for the question.
Yeah.
So the answer also here is pretty simple, and it's a built-in mechanism since the beginning of EtherCAT. It's called the distributed clocks functionality. And with this principle of the distributed clocks, we can synchronize each device in a very precise way. How is that done?
Yeah.
Also here, when the controller is sending out the frame, the controller can measure the time difference between the leaving and the returning frame, and measure that time difference and adjust the internal clocks of the devices accordingly. And this allows us, for example, to collect data of a widely distributed network in a very precise way with an accuracy of better than 1 microsecond.
Oh, this is incredibly accurate and still also incredibly fast, so excellent. Now, I think speed matters is one thing, but are there other reasons to rely on EtherCAT for the field bus communication?
In general, I think the field bus performance is underestimated because we have to keep in mind that the field bus is the core of our control architecture. One may think, okay, nowadays I have a powerful controller with multi-core CPUs, so we can execute PLC code in no time. And if I have a powerful controller and use a, let's say, traditional field bus systems, I have a powerful machine. But you may have to think again about that, because the field bus is often the bottleneck, and with EtherCAT we can now match the performance on the field bus side with the performance of the controller.
Okay, now I got the fastest network, excellent known, but the thing is that my I/O devices, they develop over time. I got new terminals, I got new functions here, measurement functions, I got safety, I got explosion-proof terminals. There are always so many new input-output modules are coming. So what do I do with EtherCAT? So I have to change the protocol, I have to update it, or how can we work with newer technologies and EtherCAT together?
And this is one, also to say one unique feature of EtherCAT, that's the stability. So we're talking about version 1.0, so to say, since 23 years. Unlike we did a lot of technology enhancements, what you mentioned to the technology, like added a safety protocol layer, like added functions for the semiconductor industry, like device profiles or the enhanced configuration diagnostic interface on the master side. We still kept the technology 100% downwards compatible, and this is unique in the industry, that you have a stable technology since 23 years, and this results in the biggest product variety, and this has a direct benefit for all the users of the technology. Why? Because they can select the product that fits to their application perfectly.
Well, now I know as EtherCAT is around 23 years, it started with a simple Ethernet port on the PC. So there's nothing special, it's just a regular port. In the old days, this was only a 100 Mbit port. Now today, at least 1 gigabit is standard. can we also utilize more bandwidth with EtherCAT, or are we stuck into 100 megabit communication?
No, we're not stuck with 100 megabit. First of all, I have to say 100 megabit is most sufficient, or is sufficient for most of the applications we have nowadays. For sure, there might be some applications that demand more bandwidth, like measurement applications or vision, if I want to include that. And therefore, we can use the latest enhancement of the EtherCAT technology, and that's EtherCAT G. And here we simply scale the 100 megabit to 1 gigabit level. And on the controller side, we only need a gigabit port, which is typically provided as standard on the IPC side, and then we can make full use of the gigabit bandwidth with EtherCAT. And with the new EtherCAT branch controller, and I call it the new magical device, we can integrate all the existing 100 megabit networks into segments and do a parallel processing of the 100 megabit networks in a gigabit branch, and therefore lower the cycle time again and make EtherCAT future-proof, and that all with the compatibility of gigabit and 100 megabit in one network.
I think it's really amazing. In this industry, working at 23 years is a long period of time, and normally things are not compatible anymore. So the key point is it's still version 1 and compatible. It improves in performance, and it is still the fastest field bus communication you can get. Oliver, thanks for the insight.